Hi, I'm Swarupa Sail, course instructor for Geotechnical Engineering 1. In this presentation, we will learn to find placement water content. Rapid method of placement water content determination is Proctor needle method. The water content used in the field compaction is called the placement water content, which may be equal to, less than or higher than OMC. It is desirable to compact at or close to OMC achieved in laboratory so as to increase the efficiency of compaction. For certain works, the compaction is done at lower than or higher than OMC by 1 to 2%. Proctor needle is used to determine water content in the field itself. It consists of needle point which is attached to graduated needle shank and spring loaded plunger. Penetration force is read on the stem which is fixed at top. To use the needle in field, calibration is done on the specific soil in laboratory. Calibration curve is prepared and this curve is used in the field to find placement water content. Now we need to know how to plot this calibration curve. To begin with, soil is compacted at given moisture content in standard Proctor mold. Then the rod with needle point is forced into the soil mass by 7.5 cm at the rate of 1.25 cm per second. After that, the maximum force which is used to penetrate this needle into the soil is read out on the scale. And this force divided by the needle area will give us the penetration resistance in terms of kg per square centimeter or Newton per square centimeter. And this procedure is repeated with different moisture content. So by knowing penetration resistance at different moisture content, we will be able to plot penetration resistance curve which is shown in dotted line. And this itself represents the calibration curve. Now we need to determine penetration resistance of soil in field. For that, the needle is forced into the soil and its penetration resistance is noted down. For example, if the penetration resistance noted down for the soil is 62, we need to project it on the penetration resistance curve, and from that point we need to project it downwards on moisture content line. So the corresponding moisture content represents the moisture content of the soil in field. The placement water content less than OMC, that is dry of optimum, may be specified for highway embankment of cohesive soils to achieve high shear strength. Shear strength is nothing but the magnitude of shear stress that a soil can sustain. And also the soil should have lower compressibility. Compressibility is the capability of a soil to decrease in volume when subjected to mechanical load. So the soil used for embankment construction is usually compacted to dry off optimum in order to achieve high shear strength and low compressibility. Similarly, the outer shell of earth dams are compacted at placement water content dry of optimum, that is less than OMC, in order to achieve high shear strength, high permeability and low pore pressure. The compaction of subgrade, that is soil below pavement and foundation soil below floors, may be done at placement water content more than OMC, that is wet of optimum, in order to prevent excessive swelling. The core, that is impervious wall in the dam, is compacted at a placement water content more than OMC, that is wet of optimum, to reduce permeability and swelling. We know that soil permeability is the property of the soil to transmit water and air. So for normal soil, permeability is more, and we can see here that the water and air is permeating throughout the thickness of the soil. But whereas for compacted soil, the flow is restricted and it is only till the top layer. So the soil used in core should have less permeability. And swelling is nothing but increase in volume when subjected to moisture. So even the soil used in core should have less swelling. Thank you.